All right, let's dive in. We're talking about one of the coolest, most powerful parts of AI today, deep learning. We're going to unpack how we're teaching machines to think, to learn, and even to see the world around them. And you'll find it's in a way that's, well, surprisingly human. Let's get into it.
So let's start with a really basic but kind of mind-blowing question. How in the world do you get a machine, just a box of circuits and code, to do something we find so easy, like spotting a friend in a picture or just getting what a sentence means? I mean, it really does feel like magic, right? But here's the thing. It's not magic at all. The secret, the big idea that kicked off this whole revolution, well, it's literally inside our own skulls. We looked in the mirror at our own brains and decided to build the future by copying that. Okay, so if we want to get how this digital brain really works, we've got to start with the original blueprint, the biological one. And I'm not just being poetic here. This isn't some clever metaphor. It is quite literally the design plan. And no, that's not an exaggeration. The folks who first started working on this stuff, they looked straight at neuroscience. They were thinking, hey, how can we build something that processes information the same way our brains do, by learning and making connections? And look, the one-to-one comparison is actually pretty wild. In our brains, right, we have billions of these things called neurons, and they're all linked up by synapses. Well, in a deep learning model, you have the digital version, artificial nodes linked up by connections. That's the whole idea right there. It's all about a ton of simple little parts working together in this huge connected web. All right, so we've got these digital neurons, these nodes, but how do you actually arrange them so they can, think? Well, that's where this thing called an artificial neural network comes in. So what is an artificial neural network? Think of it as the architecture, the floor plan for this digital mind. It's basically a system where you have thousands, sometimes millions, of these nodes all set up in a very specific structure. They're organized into layers, and their whole job is to pass information from one to the next, and hopefully make some sense of it all. Imagine information going on a little journey. First, it hits the input layer. This is like our eyes or our ears. It just takes in the raw stuff, like all the pixels in a picture. Then that info gets passed into the hidden layers. Now this is where the magic really happens. Each layer looks for patterns, and then the next layer looks for patterns in those patterns, getting more and more complex. And after all that hard work, the information reaches the output layer, which spits out the final answer. It's the part that says, yep, that's a cat, or you know what, this movie review sounds pretty positive. But wait a second. How does the network even know what patterns to look for? I mean, nobody sits there and programs it with rules like, okay, a cat has pointy ears and whiskers. No, it has to figure all of that out completely on its own. And that is the learning in deep learning. It's what makes this whole thing so incredibly powerful. And the secret? It's the same way we learn anything, really. Practice. And I mean a lot of it. Think about it. You can't learn to ride a bike by just reading the instruction manual, right? You got to get on, you're going to wobble, you're going to fall, and you adjust. An artificial neural network does basically the same thing, just through trial and error on a mind-boggling scale. So here's how that learning loop actually works. First, you just show it a ton of examples, let's say thousands and thousands of pictures of cats. The network takes a guess. Is this a cat? And at first it's going to be wrong, a lot. But every time it gets it wrong, it goes back and tweaks the connections between its nodes. It's kind of like it's telling itself, okay, that didn't work. Let's make this connection a little weaker and this one a little stronger. And it does this again and again, millions of times. With every single cycle, it gets just a tiny bit smarter until eventually it becomes a cat spotting expert. Okay, so after all that practice, all that training, what's the payoff? What can these digital brains actually do? Well, this whole process has given machines some absolutely incredible abilities. You could almost call them superpowers. So superpower number 1, computer vision. And that's exactly what it sounds like. We have literally given sight to machines. They can now look at an image or a video and actually understand what's in it. And this leads to some amazing stuff you probably use every day. You know when your phone automatically groups all the pictures of your dog together? That's image classification. And think about a self-driving car. It needs to spot pedestrians, stop signs, other cars. That's object detection. It gets even crazier with things like image segmentation, where a medical AI can look at a scan and perfectly outline a tumor, way more precisely than a human eye could. All right, on to superpower number 2, which is just as mind-blowing, natural language processing, or NLP for short. This is the big one. It's all about teaching machines to understand us, to understand our words. Not just the dictionary definition, but the complexity, the nuance, all the messy stuff that makes up human language. And trust me, this is everywhere. When your email inbox automatically knows what's junk and what's important, that's text classification. Ever wonder how a website can tell if 1,000 product reviews are generally positive or negative? That's sentiment analysis. And of course, the big ones. Anytime you use something like Google Translate or talk to a chatbot like ChatGPT, you're seeing machine translation and language generation in action. So when you boil it all down, what's the big takeaway here? It's that we haven't just built fancier, faster calculators. We've actually created a totally new way for machines to learn from experience, to find patterns all by themselves, and to solve problems we never, ever explicitly told them how to solve. And the wildest part? The whole idea came from looking at ourselves. You know, we kicked this whole thing off by just trying to copy the human brain. And in the process, we've ended up creating a kind of intelligence that's both incredibly powerful and also kind of alien. It really leaves you with a huge question, doesn't it? If our brains were the inspiration for this revolution, what's this new intelligence going to inspire next? What new discoveries, what new ideas are waiting just around the corner?